Okay. Okay. Okay, what are you saying, huh? Wait.
Yeah.
Yeah.
Why is my mouse there? Wait, what? Okay. So, we're doing complex numbers. Whatever the complex numbers. Class. Have you all ever did complex numbers? Oh, you hear me?
Yes. Yes, we hear you. No, we have not done complex
Alright.
numbers.
So, what do you think complex numbers are? Yeah, this is actually a live class.
Well, all I know it to be is numbers. I'll say it. You really can't get the number, so you just use like the letter I, and well as I can see right here, it's real numbers.
Yes, it is a higher form of numbers. Because you know the number system, right? What are the different number systems we have?
Give us the first example.
Well, we have the first system, which we call natural numbers. And those numbers extend from 1, 2, 3, 4, 5, and beyond. What's the second one we have?
We have whole numbers.
We have
Should
whole
I
numbers.
list them out?
Yeah,
Or we think to finish right? Okay. So we have whole numbers,
right.
positive integers, negative integers. I don't know if I would just keep it as integers in general,
Yeah, it is
but
integers.
It doesn't suggest.
If you say positive integers, they might as well just say natural numbers. Something. I don't know why they do that. Right. So why do we have these different number systems? Why do you have this? After writing them down.
so we can use them for different applications.
Huh? But like what
We probably,
applications? So like what applications?
uh, um, I don't know. Because who explained? Somebody explained and said you only count to usually start from 1, 2, 3, 4
Ah,
natural numbers. You just use accounting. I don't know if accounting have a specific set of numbers they use. They probably use whole numbers.
and so like so who would use integers? So say like you had say yeah we only had natural numbers, right? The first numbers we made we was using our hands account, right? Right? So you're in 1, 2, 3, 4, 5, 6, right? So but then after you have a situation where, right, we wanted to let's see take $1, right? And we wanted to divide that dollar into 4 persons. With this number system, natural numbers, right? Could we take a dollar and divide by 4 and divide it for 4 persons?
No, because it have no fractions, right?
Right. So because how when we right to divide it between 4 persons, that'd be 1/4, right? But natural numbers do not have fractions, right? So we had to make a new number system, and that one would be, well, we call it rational numbers, right? Rational numbers. So these ones, you could have fractions, right? A over B. So what happens is that they have certain problems they get, and really the numbers they want to find, or the solutions they have, that number does not exist within the number system they currently are using. So if you want a fraction, there's no fraction in natural numbers. So you have to make a whole new system. I call it rational numbers. And complex numbers is the same idea. Complex numbers, you can, in real numbers, so they had to make a new system of numbers to handle this value here. And they call that complex numbers. That is the backdrop there, right? That is the skeleton there. Huh?
Yeah.
Yes.
Alright, that's the diagram, right? So the complex number is above real numbers. Right? So that means real number is a subset of complex, right? So there's a certain form, complex numbers take, right? And there are two, right? There's the Cartesian form, right here. And there's the polar form, right? Right now we're going to deal with the Cartesian form, right? The polar form we'll deal with later. Now the Cartesian form is z, which is our complex number, equal x plus yi. X is our real number, and y is our imaginary part. Okay, so I'll label that. So this is the complex number, and this here is the real part, and this part here is the imaginary part. And I is referred to as the imaginary unit, right? Not the actual imaginary part, right? So that means a complex number is both the combination of a real number and an imaginary number. So you see, imaginary numbers and complex numbers are actually the same thing. A complex number is both the real and the imaginary number. And it always must be in this form, right? Now, that me saying that it always had to be in this form is something very key about the different rules of arithmetic we're going to learn about later. Because if you look at the syllabus, we are learning about complex number addition, subtraction, multiplication, division, square root. The point about doing all those things is so that we can have it in this form here, x plus yi. They will all end up in this form. No other form. This one. So, right. So yeah, so this is right, so if z equals a plus bi, this is how we denote it. The real part, or a of z, is equal a. And imaginary part, they denote it as im of z equal b. So, our example. So number 1. So do you have a book and pen out and thing? Hi, Mary and Samantha.
Yeah, I have a book.
Right.
Yes, I have my book.
So I'll give you number 1, right? Well, you use it later. Alright. So number 1, actually question will be, determine the real and imaginary parts of Right, so Amari, I want to do this one.
What is Z again?
Oh, Z is the complex number itself. This is that 2 here. So I want you to tell me the real part, right? The real of Z, right? And the imaginary part of the complex number Z. And Samantha, you do the other one.
I can start now.
Huh?
Can I start now?
Yeah, you can tell me one time, Gavin, right?
Okay, the real number of Z is 2 and the imaginary number is 3.
Nice. Well, imaginary part, yeah.
What's so specific are using the word imaginary part instead of number?
Well, I'm not sure exactly why. Is that way, how does mathematicians say it? But the actual number, if you say an imaginary number, that is 3i. That is both of them. But when they say imaginary part, it just talking about the coefficient of I.
Okay.
The number,
So could I also say the coefficient of the imaginary number?
yeah, essentially, yeah. You can say that as well. It still makes intuitive sense, according to ChatGPT. Because when I was asking ChatGPT, I was asking it was the difference, but there's really no difference. But mathematicians like to say imaginary part instead of, because it is technically part of I, right? Because it would have been say you had square root of 9, right? Square root of negative 9. What they do is break it up to 9 by negative 1. And now the square root of 9 would be 3. And you remain with square root of negative 1. So you get 3i. So this 3 here is indeed part of the complex number, but you can like separate it so that it looks like, so like it's real instead. So you have to note that this coefficient here, even though it seems like a real number, it actually part of the imaginary number. So this refer to that as the imaginary part or something.
Okay.
That's what I get from it. And Samantha, what you get from your question?
The real number is 5/2,
Alright,
and the imaginary number is 3.
nice. Right. So, given that, so that is great. Oh, I got through that. So, I'm teaching good. So, am I teaching good? What do you think?
Yeah, you're teaching good.
Yes. 10 out of 10.
Wow, thank you very much. So the purpose of everything about this arithmetic and division and what I'm going to teach you now, all of it, the purpose of it is to get it into this form. This form here. This is the form you always want. So that's why they always have different, they have all the different techniques of, for complex numbers, right? So now we're going to addition, right? We're going to do our arithmetic operations. First one, addition, right? So say you had z1, right, equal 3 plus 2i, and you had z2 equal 4 plus 5i. Imari, could you tell me what is z1 plus z2?
So would it be 3 plus 4 equals to 7 plus, there's a 5, right? For the Z2.
Yeah.
Okay, so would it be
7i.
7i? Okay.
So 7 plus 7i? Yeah.
Yes.
Essentially, right? So you add up your real parts and you add up your imaginary numbers separately, right? You know, just like how if you had x plus y, you can't just simplify the x and y to be something like xy or something. You have to leave them separate, right? Subtraction. Yeah, I don't think you have S here. C1 equals 4. And Samantha, if I take Z1 minus Z2, the next question here, what will be my answer?
2 plus 4i.
Nice. Simple like that, right? So now we're going to move on to multiplication, right?
1 second, 1 second. Go back up for 50 seconds.
Huh? Oh yeah, okay. Hold on.
You just go up a little bit more, please.
Oh, you're taking it down? Okay. Alright, my bad. Well, I can put the rule, add real.
Okay, if you go ahead.
Alright.
If you want, just put like steps in front. Well, you don't really have to put it, but.
So like put like if you have C1 equals right. Now we're going to multiplication, right? Multiplication. So if I have I multiplied by I, what is my answer? Samantha.
I squared.
Right? And could this be simplified to a number? Like actual like number we could see instead of a letter? Okay, I'm very feels better. So what does I represent?
I'm sure.
Oh, my bad.
An imaginary.
Oh, yeah.
Imaginary. So I is equal to square root of negative 1, right? Of which is imaginary number because we cannot really visualize what square root of negative 1 is because there's if for our real number system there's no two numbers that multiply by each other, same numbers, that will give you a negative answer. When you square them, that's what I'm saying. Yeah. So if you have a squared, say we have negative 2 and you square it, you get 4. If you take 2 and square, you get 4. There's no number that we have that when we square it actually gives us like something like negative 4. So that's why you call it imaginary number. So I is equal to square root of negative 1. So if I had I squared, what would we get?
Negative 1.
Negative 1,
Oh,
right?
what you want?
Yeah, can we square it out at negative 1 by square root of negative 1, which these square roots are cancel out. So all I remain was negative 1. So Samantha, you see that? Oh, I went too fast and I want me to go back.
No, I see it. I forget the I was negative.
Yeah, I mentioned
Was that, yeah.
So if I had
Is I
huh?
is I always equal to root of negative 1?
Yeah. Well,
Okay.
they use it to simplify instead of like having like square root of negative 9 like I showed before. Instead of having like that, it's simpler to just leave it as
To break it down.
yeah, break it down. And leave I to be square root of negative 1. Easier to do.
Okay.
So if I had I cubed now, what will that be? If you simplify it.
It'll be 1.
Would it be 1?
Oh, wait.
It will still be cubed. It will still be cubed root negative 1 because it will get back the square root. Right?
So what the final answer will be?
Square root of negative 1.
Square root of negative 1. Well, we have square root of negative 1. Well, close. Close. Once it's square root of negative 1, you leave it as I. But how we able to square, in this case, right? How we able to square both of them? We can leave it at negative 1, right? But for this one, right, you have the square root of negative 1 by square root of negative 1 by square root of negative 1, right? These two would cancel out, right, to give you negative 1. We still have to multiply by this square root of negative 1. And we know the square root of negative 1 is I. So you get negative I. So this goes to show you that no matter what power I have, it can be written in a form of I by itself. And that's why, and so this factor alone, like how when they multiply, no matter how the power I increases, you still end up with an item, is what allows us to have it in this form always, right? So I'll give you the next one. What about I to the power of 4? What will that be? Imari.
Would it be 1?
Yes, it'll be 1. Okay, you're gonna get yourself square root of negative 1 squared by square root of negative 1 squared is equal to negative 1 by negative 1 is equal to 1. Alright? Good. So you understand? So I understand this?
Yeah.
Well, you think
Yes. Yeah, 1 second.
Location. I'll call it some power by now. Well, that's exactly how the book had it. So remember the purpose of all of this is for the general form of a complex number. Because like it's like a number, right? So like any number you have will always be reduced to like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For complex numbers, it will be reduced to whatever the real number is and imaginary part by I. Always. So just keep that in mind.
Okay, you can go ahead now.
Right, so now we're going to do some, well, actual multiplication, right? Now it's more of power. I'll just show you the properties of I. So we're going to do multiplication to say, can I give you a good quadratic? 2 plus 3i by 5 plus 6i. I want you both to expand and simplify to the form x plus yi. Okay, that must always be the form.
So do it first, then Teddy will just talk to you while you solve it on your own.
You can do it first and you tell me when you finish.
Okay.
Both you and Samantha. Again, true.
Yeah.
Yeah.
All right.
Okay, alright.
All right.
Me too.
So what answer I get?
Negative 8 plus, well, minus 8 plus 27i.
Plus 27i.
Yes.
Both of you agree?
Okay, then no, I didn't work it out that far then.
Yeah. Oh, it didn't express in this form.
Yeah.
It must only express in this form.
Mm-hmm. Let's work it and let me see.
All right. So what we do? So we're gonna expand. So you're gonna get 10 plus 12i plus 15i plus 3 by 8 18i squared. So I add 10 here. You simplify the item, so that is 27i. And now this I squared could reduce to negative 1. So we have negative 18. So 10 minus 18 is negative 8 plus 27i. Samantha, understand that?
Yeah.
Alright. I'll give you our next one. Practice. 3i minus 2. 4 minus 5i. Express. Right. So this is question 2. I want both of you to find for me what A and B is. You know, or just simplify. Of course. Well, again, Drew.
Yeah, finish.
Finish?
Yeah.
Alright. So what answer I get? Your final simplified answer.
7 plus 2i.
7 plus 2i. Imari, you agree?
Two, I get 22. I'm gonna check it so fancy.
No, I make a mistake. I had to do like minus. I thought minus and I should have put a plus.
Okay, 7 plus 22.
Yeah.
So Samantha, when you fix it, you get 22?
Yeah.
Alright. Right, so again, it's 7. Right, so that'll be. Alright then. Now let's go to division. So say I have z equal 2i plus 5 all over 6 plus 3i. What do you think the form will be if I were to divide those two things? If I divide those two, complex numbers, what should I get? Like, and actually that can be number like does it form like the form of the resulting expression.
So would it be 5 over 6 plus 2i over 3i?
The form, like in letters, right? Like how do they?
Oh, in letters, like you mean like the general form?
Yeah. So what form? So if there's any letters, what form you think you'll take once we resolve the two complex numbers on top here? If we just simplify this expression, what form you think you'll get? Or where the
It
answer
would be
should
like, would it be like 2i plus 5 times 6 plus 3i all over that same thing?
The form?
Yeah.
Wait, what do you mean?
Okay, would it be like a plus bi by c plus di?
Alright. I get that, right?
Yeah.
But once we work out that, what should be our final form?
Oh, you want the final form?
Yeah,
Okay.
final form. Yeah. How the final form look?
Give me a second, I'm gonna work it out.
No, not actually work it out, just in general, the final form was supposed to look like some way. Always, no matter what.
So would it look like the same as the beginning with x plus, well, a plus bi?
Yeah, right. So is a plus a, right? So I put x, right? Right, so you must always get that, right? So the resultant, now let's remind you again, the resultant form must always look like this.
Oh, okay.
Right. That I meant. My bad. I can really explain it properly. Where? That I meant. So we are supposed to be able, so when they're asking you to divide it, they want you always to put it in this form, x plus yi, or a plus bi, anyone works. Just that form, right? So to do this, right, you gotta do something that you'll be familiar with. So if I had 3 over 2 plus square root of 2, and I wanted to rationalize that, what will I have to do?
You'd have to multiply by, I can't remember, I think it's the inverse of the denominator with 2 minus root 2.
Right, so multiply the top and the bottom by 2 minus root 2, right? Samantha, agree with that?
Yeah.
Right, and where you call that? We call this number, why multiply by the minus? Well, not why, but you actually tell me why do we do that? Multiply by the minus. And if you don't have to tell me what the name of it, if you can't remember. But why do we multiply by the negative sign here? What does this do when we rationalize it?
I genuinely don't remember.
You might remember?
I can't remember the name, but I think the reason why is just so you could cancel out the
Yeah.
root on the bottom so that you'll be
Right.
able to solve the equation.
Yeah. So it's just to simplify it, right? We rationalize so that we can have only the squares on top because it's simpler that way, right? In the same sense, that's what we're gonna do. Because we're gonna multiply by the conjugate of the denominator. And what would that do? That will remove the I term on the bottom because you end up getting I squared. And therefore all the items will be on top. And once all the items on top, we can get this form by simplifying. So what I want you to do is multiply by the conjugate. And well, I'll do it. Am I doing first one for you, or I want to try it on yourself so it might stick in memory better?
Do the first one.
Alright. So what I do, multiply by the conjugate. So the conjugate would be, well, 6 minus 3i over 6 minus 3i. So you multiply top and bottom. So you're getting 2i plus 5 right up by 6 minus 3i all over 6 squared minus 3 squared I squared. You agree with that?
Yeah.
Alright.
Yes.
And this will result to 12i minus 6i squared plus 30 minus 15i all over 36 plus 9. And then, well, you group the 12i, right? So I 12 minus 15i, that is negative 3i. This I squared here is also negative 1, and negatives by negative positive, so you get plus 6 plus 30 all over 36 plus 9, 45. So you get 36 minus 3i all over 45. I think this could simplify more. If we put 3, that is 12 minus I over 15. And that'll be in the form of, it's any form. Well, actually to get any form you have to split it up, right? So it'll be 12 over 15 minus I over 15. Do you understand that?
Yes.
Yeah.
Alright, so I want you to try one for yourself. So you have C equals to 6i plus 5 over 4i as a plus 6. Right, so I want you to, well, simplify that. So once I give it in that form, you simplify, right? Simplify 6i plus 5 over 4. In the form Now, even if they don't tell you any form, it's just it's just always it's like a what do you call that? An unspoken rule that it must be in a form. Always. So you can go ahead now. Alright, again, true. I know this one has more
Yeah.
bigger numbers. Alright.
Okay, I think I finished.
Alright, hold on a second.
I got minus 54 minus 16. Oh, wait, no, I'm going to finish separated. I think it'll be minus 54 over negative 52. So that'll be 54 over 52 minus 16i over minus 52. No, 1 6. 1 6.
Huh?
1 6, not 60.
1, 6.
No, for the numerator.
Oh, okay. Alright. Over 52?
Negative 52.
Right.
Unless the two negatives from this will cancel out to make the
And that
positive.
would result in 27 over 26 over. Nice. Samantha, you got that?
Yeah.
That is great. You all are learning very quickly. I have a bonus question. So I have square root of negative 225, right? Z equal, right? what is I, MZ, and R, E, or Z? So what's the answer? Okay, do it. Then you paper first and then answer after.
I can answer it one time.
Huh?
I can answer it one time.
Yeah, sure.
It would be root 225 by -1.
Right, okay.
And then you get 15i.
15i.
Yeah.
Alright. So IMG is what?
IMG is 15.
Alright. And RLZ equal what?
0.
Yep. RLZ is 0. Samantha, you got that?
Yeah.
Nice. Alright. So next thing now is square root, right? So I want you to find, right? Well, not find yet, but we're going to square roots now. So I have to find the square root of 5i plus, well, 5 plus 12i. Right, so say z equal, right, okay. Say z equals square root of 5 plus 12i, right? I want to find what that is, right? Or simplify it. What you think a final formula look like? Imagine.
X plus yi.
Right. It will always equal to x plus yi. Or whatever the letter you choose, right? Now you see that property, that is x plus yi, we have to use this to solve for the answer, right? Because what we actually have to do, since we know that the square root of 5 plus 12i equals x plus yi, then that means if we can find for x and y, that'll be our answer. You see that? We are fine for x. X and y. So to solve this problem, we're actually going to use that property which I was teaching about, that it will always be in this form, to find the values or the coefficient and the real part. So here's how we're going to do it, right? So you equate them, right? Equate that 5 plus 12i equal x plus yi, right? And what we're going to do now is square the both sides. Tell me if that's making sense.
Making sense.
Alright. Samantha, making sense?
Mhm.
Alright.
Yeah.
So this area resolves to what?
5 plus 12i.
Alright. Equal to
X plus yi squared.
well,
And it's expand x squared plus y squared I squared. Yeah. Plus 2xyi.
Nice. Alright, so then you simplify. So you have 5 plus 12i equal to x squared minus y squared, because it's I squared property, plus 2xyi. Right, so we are almost there, right? Now, we're almost there, right? Almost there. So, if you watch, right, we kind of have the formula. You see it here? This here, these here, right? I know this, I said this is the imaginary part, right? But because it cancels, now it actually counts as a real value, right? Just like how, like here, this negative 6i, it was once a imaginary part, but then it turned into a real part, right? Similarly, here now, you have that this here would give us our real part, right? Our real of z. And this here's coefficient of I would be our imaginary part. And so if this is our real part, right? And we know on this side, the real part equal to 5, and imaginary part equal to 12, we could say that x squared minus y squared equals 5, and 2xy equals 12. Label this equation 1, label this equation 2, and then we use this to find for x and y. Tell me if that makes sense. Or I'm going too quickly. I may want to step back.
No, I think I get it. So once you don't have the I in the thingy, then it will just be equal to a real number.
Yeah. I mean, I probably should never say that because that can have, might bring up some confusion. But you see that since I have no I, you see this is kind of like the form now that we want. Because here had no I, there's no coefficient of I here. This is just the real value, right? The coefficient of I is on this part, because this here we have I. So here will be our imaginary part. And this part here that has nothing to do with I will just be our real part. And we know that our real part here equal to 5. And we know our imaginary part here equal to 12. So you understand that? Good? Or one more?
Yeah.
Alright. So yeah, complex thing for the sake of simplicity. So now we have solved for these two. So you want to be able to use simultaneous equation as we have this, multiplication here. So we will have to do substitution, right? So 2xy equal to 12. So you do the simpler one. The simpler one, which would be 2xy equal 12. So 2xy equal 12, right? We can make y the subject of the formula. So y equal 12 over 2x, which is equal to 6 over x, laid by equation 3. And now we substitute 3 into 1. So let's bring this back down. Right, so equation one was what's that, right? So you substitute now, so you have x squared minus 6 over x squared equal 5, and right, equal 5. So you get x squared over 36 over x squared equal 5. See, so what we do now, we want this to be a what I mean, right? We multiply. Oh, good. Why do we have it? Alright, seeing this, right?
Yeah, try substitute it into the 2xy and see if that might look better.
Alright. It still work, but it might be a little treacherous.
More complicated.
Yeah. All right. So yeah, that'd be much easier, right? Wait, would it?
You can leave that part. You can leave that part and just substitute it back into the same equation. I think. I think you can try that and see.
All right. Well, I'll leave it here then. Let me pull this here, right? So we have, so let me x squared the subject. So you get 5 minus plus y squared. Substitute, label that equation 4. Sub 4 into 2. And get 2x, wait, 2 y squared y equal 12. You get 10. Yeah, I think this one actually will be more troublesome. Okay.
Don't you know what I mean? I mean, like, you see how you have this y equal to 6 over x?
Yeah.
You can substitute into equation 2xy equals 12. Oh no.
2xy equal 12.
Yeah.
Into what? To which one?
Equation 3 into equation 2.
Equation 3. Oh, well, we wouldn't be able to do that because our equation 3 came from equation 2. Okay, if I did that, I'll get 2 over 2x over 6x equal 12. And you're going to get 12 equal 12.
Okay.
Well, I go on for, well, I know we have the question, but with that way, they wouldn't give anything, I wouldn't expect they give anything. Okay, this is not actually that complex because it's not cubic. So what you get, you multiply both sides by x squared, right? So you get x to the power 4 minus 36 equal 5x squared. We put everything on the left side, so you get x to the power 4 minus 5x squared minus 36 equals 0. And what you can do, you can use u substitution, right? So let u equal x squared. So you have u squared minus 5u minus 36 equals 0. Now they use so I understand that?
Yeah.
You see what it is, right? Alright. So now solve for u. Tell me what you get, and then we'll go on. But tell me what you get for u when you factorize, or you call it, use the quadratic formula. We're done, so again. I get well, yeah, answer. Right then.
I still looking it up.
Okay.
Yeah, I get 9 and negative 4.
9 negative 4? Nice.
Yeah.
So u equal 9
Yeah, that's true.
negative 4. So that means x squared, right? Because u is x squared, right? Equal to 9 x squared equal negative 4. So that means either x equals plus or minus 3 or x equal, well, 2i, right? Now, recall, right? So we got two values. We got, well, three values for x, right? Um, you think we should use? You think we will use the 2i? You think the 2i valid for x,
No.
and why not?
I really don't know how to explain it, but because they won't really get a proper value if you try to use it in an equation.
Well, 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 not I couldn't use it, but like there's a certain part x belongs to which does not allow it to have an imaginary value. Like,
Right, because it's supposed to be in the form x z equals x plus y.
but yeah,
I.
and x squared was a real value. You said that x squared was the real part of z, so that means it could never have an imaginary part. So since x is real, so we're going to say since x is real, x must equal to plus or minus 3. So you have two values, right? And now we're going to do is substitute it, right, back into equation 1, right? Well, equation 2 can work too, yeah. Now we use equation, wait, actually, yeah. Equation 2. Because equation 2 is simpler, right? So once we find x, now we're going to say now, when x equal 3, 2 of 3y equal 12, so y equals 12 over 6, which equals 2. So one of our solutions is that the square root of 5 plus 12i equals 3 plus 2i, right? And the reason, well, 2, remember y is 2, right? And if you come up here, we had 2xy. So, the real part will be 2xy. Okay. Okay, my bad for this. Just a minute. Okay. But so if you're being confused, I'm now looking at the textbook, right? And they have an x equal 3, you plug it in and get 2, right? So it says 3 plus 2i. But now recall that it had x squared minus y squared plus 2xy. Now feel you might have to sub into this first. And then and that should be the answer. You think so?
Sub into what?
Huh?
What we had to sub into?
I remember the equation we got was 5 plus 12i equal x squared minus y squared.
To sub into this thing right here.
Oh, my bad, sorry. Right, so, yeah, the formula we had was the square root of 5 plus 12i equals x plus yi, right? So we got x, and we find for y. So that means one of our solutions would be, since when x is 3, y is equal to 2, one of our solutions is 3 plus 2i. And then when x equals negative 3, y 2 by negative 3y equals 12, and y equals negative 2. So our next solution is that negative 3 is that the square root of 5 plus 12i equals negative 3 minus 2i. Alright. I know I kinda get down. I have to check there. So you understand that, or we go over through it because of that pause there?
Just go over it like one more time.
Alright. So we first start off, right? So when you find the square root of a complex number, so you equal square root of 5 plus 12i, you must first establish that its final form will be x plus yi, right? So what we're gonna do is equate those two values, the square root of 5 plus 12i equal and the x plus yi, and then expand. Well, we square both sides to get rid of the squared root sign on the left. Then we will get our form. When you simplify, we get 5 plus 12i equal x squared minus y squared plus 2xyi. Now we know that the real part, right, for y plus 12i is 5, right? For z equal the square root of 5 plus 12i, that's 5, right? And but we also know that for on the right hand side, we say the real part is equal to x squared minus y squared. On the left side, we see the imaginary part is 12. On the right side, we see that that's also equal to 2xy. So what you can do now is take the real part of z, right, which is 5, and equate them. X squared minus y squared equals 5. And liberalize equation 1. I think the imaginary part on the left side is 12, and equate it to the imaginary side on the right side, 2xy. Because they have to be equal for it to be true, right? In order for this, the right side here, x squared minus 5 squared, for this to be true, it must be equal to 5, right? And for 2xy, for that to be true, it must be equal to 12. So we know that we can equate them, and we get ourselves two pairs of equations, of which you can solve using substitution. So what we do now is take the 2xy equal 12, and we make our next equation 3, by letting y be the subject instead, right? Now you don't have to really do this. First you could have put 2x equal y equal 12, and then put y equal 12 what? 2x, and then label as equation 2. But that's how they'll do it first, and then make our third equation out of it, right? And once we have this third equation now, which has y as the subject of the formula in terms of x, we can substitute this into equation 1. Once we do that, we get ourselves a quartic equation, right? We get ourselves x squared minus 6 over x squared equal 5. We multiply both sides by x squared and we get a quartic equation. However, due to it not having a cubic term or x term, we could let u equal to x squared and simplify it to actual quadratic formula. Even though it have the fourth term and the square term here, because how we don't have the cube term and the x term by them together with the equation, we could actually simplify it to a quadratic. And once we get this quadratic, now when we solve, we get u equal 9 or negative 4. We get x squared equal 9 or x squared equal negative 4. So that means x must be plus 3 or minus 3 or x equal 2i, but it cannot be 2i because x is a real number. We just show that here. X here is real, right? So you know that the only two solutions we have is that x is equal to plus or minus 3. Now we take back the second equation now, 2xy equal 12, and we use when x equal 3 and when x equal negative 3 to solve for y. So when x equal 3, we get 2, and when x equal negative 3, we get negative 2. And since we know that the form of our equation x plus yi, our solution for the problem will be the square root of 5 plus 12i resolves to 3 plus 2i or negative 3 minus 2i. Yeah, I probably could have done way better than that. But you understand?
Yeah.
Alright, so I want to take it down and then do one for yourselves? Or just do one for yourself, one for
Actually, just now I am, so
right.
I guess
Yeah, now
we could take it down.
You could just do like, just take it down. You want to do the example or you don't think we got time for that?
Well,
Like,
you're confident. Well, I think I'll get 3 if I give you a question, a problem question, or I just want to take it down on tomorrow. Well, it's tomorrow, eh?
it's tomorrow, yeah.
Who again, right?
I guess, yeah, we could take the question today and solve it tomorrow
Okay.
at the beginning of class.
Alright, yeah.
What tomorrow is? Tomorrow is just doing questions?
Tomorrow
or-
is Thursday.
No, what are we doing here
Oh,
tomorrow?
But we can continue, I guess.
okay, yeah, we just
We could just
continue.
continue one time.
By the way, the end goal is to answer these.
Mm-hmm.
This is the top hardest questions you can possibly get, according to ChatGPT.
Hardest?
Yeah. I asked ChatGPT
Like-
the hardest for Cape level, like we could possibly
Okay,
get.
for Cape level. Okay.
ChatGPT solves it.
Yeah, they had these answers in it down.
Okay.
So once we finish the whole complex numbers, we should be able to do this. And if we're able to do it, it means that we're good and we're ready.
Everybody going
Okay.
to school tomorrow.
Yeah. What happening tomorrow?
I don't know, tomorrow's the end of the week. I just want to know if everybody was going. Because most of the class are going to be there.
What you said?
No, that is Friday. Friday, Enviro students will
I said I was the 17th. Okay, never mind.
So, okay, so I'll give you the question then, right?
Yeah.
Right, so the question I want you to solve. Right, the question.
Oh, and Moses, when we're done with this meeting, you could either add the recording on the Google Classroom, or you could send in the class chat in our group chat, and I'll add it to the classroom.
Alright. Question. So, sounds good. I mean, simplify. Yeah, that you question. So the important thing to take away is the form. What is the form?
X plus y. yi.
Great. But soon enough, you'll learn that it's actually an X form, the polar form, of course. So I won't be able to say that again. But for this context, it's always in this form.
Okay, cool.
Alright. Will I get you?
Yeah.
That's not.
Alright. So how you think this class was?
Very good, very informative. It was nice and detailed. You answered all the questions.
So they
So
learned
it was
it?
good.
So you learned?
Yes, we did. Yes,
Yeah.
we did.
I'm glad to know that. Huh. I was actually a difficult, yes. Wait. Fireman technique, yes.
No, you did a good job for what you had.
Yeah.
Thank you very much. Alright. So that is the class done?
Yes, for today.
Alright. Well, I'm not sure if the video will be able to be uploaded because it might be big. So I might have to put it in class at one time. I mean, yeah.
Okay.
Google Classroom.
Yeah, you might go ahead and do that.
Just put the announcement or something, or
It will come up as an announcement, but I don't think that should matter. I'll just have to figure out how to organize it.
okay then.
But it will be there.
Alright then. Well, have a good day, everyone.
You too. Bye, guys.
Okay, you too.
Bye.
Bye.